Hey guys, we're going to keep going here with this slope stuff. So we got 4.2, we're talking about graphing linear functions. So a couple of vocab words. The y-intercept, so this is the vocab, I meant to have that highlighted. The y-intercept is the point where the graph crosses the y-axis. Okay, so if I'm looking at this right here, I have y equals negative 3/4 x plus 5. It's always the constant, or the number that's alone, without a variable by it. That's the y-intercept, and what that means is that's where the number crosses the y-axis. Remember, the y-axis is the vertical one, so this crosses here. That means that this point is on the graph of this equation, so 0, 5. Okay, now from there, we could use slope to graph this, and we'll be looking at that in just a second, but kind of a precursor is, remember, this means rise over run. It says the slope is negative 3/4. So my rise is go down 1, 2, 3, and my run is go over 1, 2, 3, 4, and that's where my next point would be. So I'd start here, then I'd start here, and that slope would continue in this direction forever, as well as in this direction forever. So that's kind of just a precursor as to what we will be looking at. A couple other vocab words, write these down, so you'll want to pause. An equation written in the form of y equals mx plus b is in slope-intercept form. So that's what this is called right here, slope-intercept form. The graph is a line with a slope m, this is my slope, and a y-intercept b, and I just talked about what that is. A linear function is a function with points that lie on a line, and in math, a line is a straight line. Here's your funny quip for today. If I ever left teaching, I don't really consider ever leaving teaching, but if I did, here's a job that I think I want a job cleaning mirrors. It's just something I could really see myself doing. That's deep right there. Finding slope and y-intercept. Find the slope and y-intercept of the graph of the function. All right, so the first thing, you could just identify this by m for the slope. Remember, that's the value by the x. So the slope on this one is 2, and b is my y-intercept, and in that case, this one is 4. On this one, the slope is negative 5, 6, and the y-intercept, be careful, it's minus 7, but that minus goes with the 7. So the y-intercept is negative 7. Okay, if you could identify these two things out of a slope-intercept function, it's going to make it a lot easier for you to graph. So here's one for you to try. Go ahead and pause the video and then identify this. This first one, the slope is 1. Remember, the assumed coefficient in front of a variable without a coefficient is 1, and the y-intercept is negative 3. Hopefully you got the same thing. All right, there's more than one way to graph. So this first method is by making a table. So when you make a table, you just start with x values, you pick these x values, and you substitute them in. So it says graph the function 3/5 x plus 1. So I do 0 times 3/5 plus 1 is 1. 1 times 3/5 plus 1 is 1 3/5, or 1.6. 2 times 3/5 is 6/5, plus 1 is 2, and that'd be 1/5 or 0.2. And so, in other words, all you're doing on all of these values is you're taking this x value, you're putting it in to find a y value. Take this x value, put it in here and find the y value, and so on. And then you just plot these points. Then you kind of start seeing the pattern that develops. That's one way to graph. The other way to graph is by using the y-intercept and the slope. So it says, same graph here, graph the function 3/5 x plus 1. So the first thing that you're going to do is to graph the y-intercept, which is this value. I graph the y-intercept, which means this is where it crosses the y-axis, so I have my point right here. And then I use the slope, which if you remember is rise over run, and the slope is 3/5, so that means from this point I rise 3, 1, 2, 3, and then I run 5, 1, 2, 3, 4, 5. And there's my next point. And I connect those 2 points, it gives me a line. I could do it again, rise, 1, 2, 3, run. 1, 2, 3, 4, 5. There's going to be my next point, and that continues on a straight line. All right, so that's really, really straightforward. Here's one for you to try. Go ahead and pause. You could use the method of your choice. I'm going to pause and put in the answer. All right, here's the answer. This is what your graph should look like, depending on whatever method you use. I don't really care, but both methods would produce a graph that looks like that. Let's keep going. Here's a note about lines that go through the origin. Take a look at this graph. Y equals 2x. What's the y-intercept? Well, hopefully you see that the y-intercept is right here, so that we would say that the y-intercept is 0. The y-intercept on this particular graph is 0. So here's an important idea. The slope, make sure you copy this in your notes, the slope-intercept form of a line that intersects the y-axis at B is y equals mx plus b. The slope-intercept form of a line that intersects the y-axis at the origin is y equals mx. The reason is, if I were to write this out with that, I'd have y equals mx plus the y-intercept here would be 0. Well, if I add 0 to anything, it's itself. So if the y-intercept is 0, it's just not necessary to write it. So it's just y equals mx. This is the graph of 2x. That's what those look like. Don't let those throw you off. They're actually simpler than this, but I see students get messed up because it doesn't come in this form. They memorize this form really well. This one, for some reason, throws them off a little bit. All right, so graphing functions of the form y equals mx. The temperature of a substance in degrees Celsius before and during an experiment is given by the function y equals -4/5 x, where y represents temperature, x represents time in minutes. Okay, so first of all, we're doing time, which means everything needs to exist over here. Okay, you can't go backwards in time, so I'm starting at 0. Because the y-intercept is 0. That's what I was just talking to you about. And then from here, I use this slope. So I'd go down 4, 1, 2, 3, 4, and then over 5, 1, 2, 3, 4, 5. And I could do that again, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, and that is the way that the temperature would change. So it would be going this direction. This is a graph that represents that. Again, if the x value is time, then I don't have this side because you're not going back in time. We're only looking right here. So notice that the temperatures are down into the negatives. Okay, so we're obviously dropping temperature in this experiment. Here's one for you to try. Go ahead and pause and try to graph this one on your own. All right, that's what my graph looks like, so hopefully you got something similar to that. And that's it for today, so I hope you took good notes, and I will see you in class.